So today we are going to graph exponential functions and find their horizontal asymptote while examining their domain and range. So today is going to be a big lesson. There are going to be a lot of information and a lot of examining or observing that you're going to need to do. Okay. So we've been looking at properties of exponents and functions, and now we're going to put all of that information together so that we can see what a graph will look like. Okay. So an exponential function is any number. So you have f of x equals some number, we'll say 2, raised to some power x. We talked about this before when we were talking about polynomials. This would not be considered a polynomial because it has an exponent that is a variable. So what we're going to do is we are going to look at this function here. Okay. So here's the general shape of an exponential growth function. And these are the type of functions that are currently being looked at by the CDC to determine whether or not we can open the United States safely. At first, our nation looked like this when we were going through at the beginnings of COVID, where there's hardly any outbreaks and there's hardly anything going on with the virus. But as we continued to do things that would not stop the numbers, there was an exponential growth that happened that caused people to get other people sick. And an example of that is when you have one person who has the virus and says, I think it's just allergies, I'm going to be okay. Then they go to a family member's house, and that family member's house has, let's say, 2 to 4 people in there. So now that one person infects those people, and those 4 people thinking, oh, this person just might have allergies, we're okay. Those 4 people get infected, or maybe 2 out of those 4 people get infected, and then visit other people, and that's how exponential growth is happening. So as a mathematician, we like to figure out what are some pieces of information that are going to help us be successful, and what numbers make sense and what numbers don't make sense. So we look at what's called the domain and range of the function. So looking at this function, what values can exist for the domain? So looking at this graph, it goes infinitely to the negative side and goes infinitely to the positive side. So the domain, for the most part, all functions are going to have a domain of negative infinity to positive infinity. Are there any questions about that so far? You're always pretty much going to be able to get any number you want to pick, and you're going to get some value of an answer. Questions? And this helps in science too, because you are going to examine like populations of growth or decay, things of that nature within the environment. Okay, so like we say, the domain of the graph determines our x values. Okay, now the range. What values can we see the range becoming? Or what values can the range not go to? Where's the lowest this graph is going to go? In terms of numbers, what do you think the lowest this graph is going to go? In terms of the y values, -2 would be right here. So do we see the graph even getting close to -2? No. Is the graph ever going to reach -1? No. Is the graph going to touch 0? Or is it getting close to 0? Yes. The graph is getting close to 0, but it's never going to reach it. So the range is going to be x is greater than 0. And the reason why is because the graph is never going to be 0, but it's going to get infinitely close to 0. And this is what a new vocab is. An asymptote. An asymptote is an invisible line. An invisible line where the function will not touch. So our invisible line is pretty much going to be at y equals 0. Y equals 0 is what we call our horizontal asymptote. Are there any questions about that? A lot of this is just observation. A lot of today is going to be you looking at a graph and being able to determine information. The homework is going to be a lot of trial and error. I just want to throw that out there to you. In math, we do have to use a lot of our observation skills to determine how to solve a problem. So now I'm going to show you an example. So we are going to graph some type of function. And typically the values that you're going to want to use are -2, -1, 0, 1, and 2. And so they tell us that they give us this function, y equals 2 to the x. So now we're going to input the numbers so that we can find out what our values are going to be. So y equals 2 to the x. Let's input -2. So y, or 2 to the -2 power, what is that going to equal? And don't say -4. We have a negative exponent. Not 16. When we have 2 to the -2, remember we have to make it into a fraction. And what's 2 to the second power? 4. So the answer is 1/4. Okay, so now 2 to the negative 1, what do you think that answer is going to be? Not necessarily 2, but 1 over 2. Very good. So 1/2. Okay. 2 to the 0 power. What's anything to the 0 power? That's 0. Anything to the 0 power equals 1. Okay. And then 2 to the first power. That's going to equal 2. And then 2 to the second power. That's going to equal 4. So now that we have our points, we are going to want to plot the points so that we can draw a smooth curve through all those points. So we're going to start off at -2, and 1/4 is going to probably be right here. And then at -1, right here. At 0, right here. 1. There we are there. 2. Here. And you can venture out that the graph is going to get infinitely closer going down this way. And then 2 to the third power is going to give us 8. And that one's going to give us some high number over here. So from left to right, what do you see happening? What do we see happening in this graph? Is it getting infinitely bigger, or is it getting smaller? Very good, it is increasing. So we're seeing that this graph from left to right is getting bigger, bigger, bigger. And on the left side, we're seeing that the curve is getting really close to 0. But the question is, will we ever get the answer 0 for this problem? No. So what do you think the range is going to be? Are we ever going to get the answer 0? And you said no. So y is going to have to be greater than 0. And I made a mistake on the last one. It should have been y is greater than 0, because that's our y answers. But very good. We notice that our y is always going to be greater than 0. And our horizontal asymptote is going to be at 0. Okay, does that make sense? If we were to look at this problem, our domain, we're going to see that we can pick any value we want in terms of our x. So that would give us -infinity to +infinity. Our range is y is greater than 0. Our horizontal asymptote, HA, that's how I'm going to abbreviate it, is going to be at technically y equals 0, because we're never going to cross where y equals 0. Is this making sense? And you may have to look at this video again just to make sure. Okay, let's try a different example. So do you guys, well, this one, whenever you see that there's just going to be some number to some power, you're going to see the same behavior, okay? So you're going to see that once you plug in some values, like -2, you plug them in, and you're going to see that you're going to get some numbers. And the cool thing is when you do negative numbers that are the same on both sides, you're going to see that like they should kind of match. So then for just numbers to raise some power, you're going to see the same types of behavior. You're going to keep seeing that our graph is going to get infinitely bigger. Now, does our domain change? Are there any restrictions on what we can pick for our domain? And the answer is no. You can always get negative infinity to positive infinity because we're always going to be able to pick whatever x values that we want. Now in this case, what is our range going to be? What is our range? Good. Our range is going to be y is greater than 0. And where do we see our horizontal asymptote? We see that it is not crossing that line. So our horizontal asymptote is at y equals 0. The range and the asymptote kind of tell the same story. Questions? The horizontal asymptote is just saying, this is basically asking, where is the invisible line? So the invisible line is basically where the graph isn't going to cross. Because if we were to pick like -3, we would see that we're not going to get the answer 0. It's just going to keep getting smaller and smaller, like 1 over 64, 1 over 256, 1 over something. It's getting smaller and smaller and smaller. It's never really getting to 0. It's getting close to 0, but it's not going to be 0. Okay? So now I'm going to show you another example. This one got a little messed up when I didn't fix the print. But they tell us y equals 2x plus 2. This is different because they gave us another number. They gave us a second number being added to it or subtracted to it. So we have some number here, 2, and they still tell us to use -2, -1, 0, 1, and 2. So we're going to plug those in. Two to the -2 we saw as 1/4 plus 2. And this is where 1/4 we know is, in a decimal, is 0.25 because it's a quarter. So this is technically 2.25 or 2 1/4. Here we have 2 to the -1 plus 2, which is 1/2 plus 2, which is the same thing as 2.5 because half is 0.5. Then we have 2 to the 0 plus 2, which is the same thing as 1 plus 2, which equals 3. 2 to the first power plus 2 is 2 plus 2, which equals 4. And then 2 to the second power plus 2 is 4 plus 2, which equals 6. So here we're going to see something a little different. We're going to see a shift in our graph. We're going to see that our graph is pretty much going to be increasing at some rate. But you're going to see in this one that our graph is never going to pass what? Where is our horizontal asymptote? The answer is in front of your face. Very good, Paola. You're going to see a value that our graph isn't going to pass, and they immediately give it to you in the question. Put in the chat, what do you think the horizontal asymptote is going to be? The answer is in front of your face. I'll give you extra credit if you can tell me what it is. Or what do you think it is? It's staring right at you. Very good, Kim. What do you think? Take a guess. It's right in front of your face. It's telling you. It's saying, look at me. Think about it. Look at it. Look at it. It's right in front of your face. Dare I say, it's even underlined for you. It's given to you right there. And where it is right here. They give you the horizontal asymptote right there. The second number is always going to give you the horizontal asymptote. So our domain, like I said before, is -infinity to positive infinity. What do you think our range is going to be? Very good. Y is greater than 2. And where's our horizontal asymptote? Very good. y equals 2. And that's it. So here's the last thing, just to kind of cement that for you. So the asymptotes. How can we use the equation to predict where the asymptote will be? And the answer is, it's always the second number. So for this problem, what do you think? Where do you think the asymptote is? You don't have to draw the picture. Just tell me, where do you think the asymptote is going to be? At y equals what? Y equals, it's always the second number. So in this case, y is going to equal 3. The second, y equals -3. Y equals, what do you think? -19. And the last one, y equals -6. And that's it.